Hi there, thank you for watching this tutorial video on the fixed nozzle slow landing in the AV-8B Harrier. I know it's got a very exciting and memorable name, so if you ever forget what it's called, just remember it by its more memorable and more punchy acronym, which is the FNSL brackets S. Very exciting. So what's the difference between a fixed and a variable nozzle slow landing to start with? So fixed nozzle slow landing is the one you're going to do 99% of the time. Your variable nozzle slow landing you're going to use particularly when you have marginal engine performance, so it's more of an emergency procedure. What's the difference between the fixed nozzle slow landing with stall flaps and with auto flaps? So the auto flaps one you mainly use when there's FOD on the runway. As previously described in the short takeoff video, FOD in DCS is limited in its modelling to, is there something on the runway or is there not? If there is, it's probably going to be the carcass, whichever dimwit crashed before you, so just adjust your landing point and land ahead of it or land short of it and stop in time. So ultimately, you're almost always going to use the stall variant of the fixed nozzle slow landing for 99% of the time, and then you're going to use the stall variant of the variable nozzle slow landing for when you have an emergency. So the fixed nozzle slow landing is fairly straightforward. There's no pre-landing data assignment. We're just going to set ourselves up for a standard approach as you would do for a straight in. So we're going to set ourselves up for 8 miles at 2,000 feet. And then we're going to fly down onto the runway, and at about 2 miles I'm going to bring the nozzles back to 60 degrees, and then just readjust for airway and on speed, and then perform the landing as you would a conventional landing, except you've got the nozzles back to 60, and then you do your positive nozzle braking. So it's actually very straightforward. If you ever find yourself in a situation where you can't do a fixed nozzle slow landing because of the crosswind, you've got two options. You can either do a conventional landing, which allows you to fly faster and therefore land in a great crosswind, or if you're light enough, you could do something that is either a blend of the rolling vertical landing and the vertical landing, or just do a pure vertical landing, and that will allow you to point the nose into wind completely. Okay, so let's close the throttle, bring out the air brake, and start descending down. I'm going to designate the runway here, and before we actually commit to the approach, we're just going to update our aiming point and make sure that the system designation for that waypoint is actually where the intended DLA is. So it's important to remember with the Harrier, more so than other aircraft, having an accurate designation of the DLA is important. Because obviously when you get to the key, it's so precise that you need to be at 325 feet at 0.6 miles. Obviously not as important for the slow landing, but it's a good habit to maintain anyway. Okay, on the right MPCD, I'm just going to bring up the DMT, which is currently in the INS mode, and hopefully when we spin around, we'll be able to pick that up. Okay, let's start a gentle turn, now that we're at about 8 miles. We're going to bring the scale down. So delta distance is reading 6.4. So nice gentle turn, was looking for 2,000 feet. Runway is over there. You can just see that light patch. Okay, we're at 9 miles, we're at 3,000 feet. We're going to continue this turn. Actually, we're going to straighten out the turn for a moment. And preemptively, I'm going to pop the aircraft into VSTOL master mode, because that is the first thing you would do as part of the landing configuration checks. And we're going to keep that air brake out. Delta distance coming down nicely. We're a little bit low. We're a little bit shy of the 8 miles, and I'm going to turn onto the runway heading. Quick note, I have got the QFE set because this is straight off the back of the other video. Yep, the DLA is selected as desired for 1,500 feet, so we're just going to adjust and we're going to start descending at 6 miles. So remember, it's 500 feet for every 2 miles. So let's bring the power down to adjust for the on speed. Bring the flaps down and bring the gear down. There we go. Adjust for the balloon. Store stops clear. And 6 miles wind start to descend. So we are looking for between 10 and 12 units of AOA. Decenter that there so that we can see it a bit better. And we're just using the checkpoint altitude. So we're a little bit high. We want to be at 1,000 feet at 4 miles. Bring that scale down a little so that we can see a bit better. There we go. And we've got a right to left crosswind here, so the nose is going to end up pointing slightly right, so we're updating our aiming point by double checking the track on the EHSD. So 4 miles, 1,000 feet, that's good. AOA is a little bit low, so let's trim and adjust the power back. There we go. Quite a lot of turbulence at the moment. There's the runway there, so we're a little bit off to the right of the center line. Just adjust ourselves left. Good scent line correction. You want to be proactive with it, so you want to get back on the scent line as soon as possible. Do not just aim for the runway. Okay, there's 2 miles just about coming up, so we're going to bring the nozzles back to 60. Anticipate the balloon, put the nose down to prevent an increase in height. Allow the rate of descent to drop again, and then readjust the power for AOA and rate of descent. 2 miles at about 500 feet, that's good, and we're back on runway center line there, so I'm going to keep bringing the nose right to adjust our track to meet the intended runway center line. Remember, this is why it's so important to have the course line, because you don't have the ability to view a reflected velocity vector in the VSTOL mode, so you need that course line. 1.1 miles, and we're at 210 feet, so again, this is different to the rolling vertical and vertical landing in terms of the key positions, so we don't need to worry too much about that height. I am, however, going to reduce the rate of descent because I want to avoid those trees. Just adjusting, cross-referencing that track, 0.5 miles. Now, rate of descent's 350 feet per minute, so that's good. AOA is 11 units, so that's good. Alright, let's increase that rate of descent now that we're clear of the trees. Allow the aircraft to descend, watch your AOA, and in close, kick off the drift, opposite aileron, close the power, which is hot on the horizon. Close the power nozzles all the way back, add power no more than 60%. Once below 50 knots, close the power, reset the nozzles, and hold the brakes. And now that we're slow, introduce nose wheel steering.
Caution.
And vacate the runway. We'll pretend this is a taxiway to our left. Okay, and we'll stop here. So quite a bit to keep an eye on in that terminal phase. So throughout the approach, obviously, like I say, you can't get a reflected velocity vector for the VSTOL mode, so you can't see where your aim point is based on the velocity vector in the left and right sort of azimuth field. So you have to be able to update yourself by glancing at the track on the EHSD. So you're looking in 2 places. So you need to keep that lookout attitude instruments work cycle going. You're starting at 8 miles at 2,000 feet, or in this case it was 6 miles at 1,500 feet, and you checkpoint yourself the entire way down, so it's 500 feet for every 2 miles. So at 4 miles it's 1,000 feet, at 2 miles it's 500 feet, and obviously 0 miles hopefully it's going to be 0 feet if you've done everything right. And you're looking to be 10 to 11 units of AOA. You can bring the nozzles back at 4 miles if you so wish to 60 degrees. I brought them back at 2 miles for expedience. Once you get more confident, you might be able to do that too, or even later. However, if you're struggling, do it at 4 miles. Make sure that you keep the AOA throughout. Remember, when you bring the nozzles back, you don't want to touch the power. You want to bring the nose down to avoid climbing, and then reset the power as the aircraft slows down and some of the lift transitions from being generated by the wings to being generated by the engine. As you come in close, it's really important that you put the witch's hat on the horizon so that you don't get a tail strike. You do a standard crosswind landing as with any aircraft, so you kick off the drift with the rudder and you apply opposite aileron to prevent one wing from coming down. Once you're down, you'll then find that you need to apply opposite rudder to keep the aircraft going straight on the runway. Close the power just before you touch down so that you don't bounce, and then immediately go into positive nozzle braking. Once you're below 50 knots, close the power, reset the nozzles, hold the brakes gradually. Once you're about walking pace, re-engage the nose wheel steering. If you do it any faster, the likelihood is that the nose wheel steering is going to point you in the opposite direction, and you're going to essentially flip the aircraft. I hope you found this tutorial useful. If you have any questions, please feel free to contact me. Thank you for watching.